Hello students, welcome back. So today we are going to start with a new chapter of solutions and colligative property. So before going into the solution chapter, so we'll basically discuss some of the most important concept of 11th class, that is concentration term. Because in this chapter we are going to use a lot of concentration term and question directly or indirectly would be related to these topics. Okay, so let's start the lecture. Okay. So first thing which we define over here is what is solution. Solution is basically nothing but a homogeneous mixture of two or more components. Okay. So when we mix two components, if we get a homogeneous mixture, then we say it is a solution. Okay. So basically solution is comprised of two important components. One is the solute and the other is the solvent. Solute is basically the component that is taken in small amount. Okay, we also say that solute is the component which gets dissolved. Okay, and solvent is the component which is taken in large quantity, or basically it is the component in which the dissolution is happening. So solute is something that is getting dissolved, solvent is something in which the dissolution is occurring. So in solution we are majorly interested in finding the strength of the solution. Okay, now what is the strength of the solution? We basically want to get the amount of solute present in a given solution. So the amount of solute present in a given volume or given mass of a solution is called as the strength of the solution. So as you can read it from the definition, it is basically defined as the amount of solute present per volume or mass of the solution. So there are few basic concentration terms or the strength of solution term that you should know. The first being mass percent. Okay, so what is mass percent? It is basically mass of solute in grams divided by mass of solution in kg, solution in grams. Okay. So mass percentage is basically the mass of solute that is contained in a given mass of solution. Because it is a percentage, so we will multiply this with 100. Okay. So suppose we have been given that a solution is labeled as 36.5 by mass percent. Okay. So suppose a question is given to us that 36.5 mass strength or by mass percent of HCl is given to us. So we'll just decipher this information, we'll just decode this information, we'll say that in a 100 gram of solution we were having, so in 100 gram of solution we were having 36.5 grams of HCl. Okay, so whenever mass percent is written over there, so we are going to just decipher that concept and we are just going to write in terms of the text. Okay, so 36.5 mass percent HCl means in a 100 gram solution we have mixed 36.5 gram of HCl. So if you use this data, so the mass of solute is 36.5, mass of solution is 100 into 100, so you will get 36.5 mass percent. Okay, so whenever you have been given mass percent, you just have to decipher or decode the mass percent given to you, that we will directly use in the question. The second very important concept is mass by volume percent. So this is also written as mass of the solute in grams divided by volume of solution in ml into 100. Okay. So suppose we have been given a solution which is labeled as 36.5 mass by volume percent. Okay, so what does this mean? This basically means that if we have taken 100 ml of solution In that we are dissolving 36.5 gram of HCl. So we can say that 100 ml of solution contains 36.5 gram of HCl. Okay. So these are the very basic elementary concept that you might have done in mole concept also. So we are just going to revisit it so that whenever it comes in the questions of this chapter, we will be able to solve it properly. So you can just write it down. Okay. So third important term is, now if you look at this, this is basically mass upon volume. Now what is density? Density is also mass upon volume, but does density indicate strength of solution? Density is basically defined for the entire solution. So density is mass of the solution upon the volume of the solution. Okay, so that is for the entire solution. It does not represent the strength of solution, whereas mass by volume percent is mass of solute only. Okay, so mass of solute upon volume of solution in ml. So density is not a strength of solution term. The third that you should know is volume by volume. Okay, volume percent. Okay, also it is known as volume by volume. Okay, so this is basically the volume of solute in ml upon volume of solution in ml. Into 100. So suppose a solution has been given to us which is mentioned as say 10% volume percent, 10% volume by volume, or 10 volume percent of H2SO4. So 10% volume, okay, of H2SO4 means that 10 ml of H2SO4, or we can write this as 100 ml of solution contains, so we can write this as 100 ml of solution contains 10 ml of H2SO4. Okay, I hope this is clear to everyone. Fourth important term is mole fraction. Okay. Now what is mole fraction? Mole fraction is generated by small x. Okay. Mole fraction of a component is given by the mole of that component upon the total moles. Okay. So mole fraction of any component, say it is the ith component, will be equal to the number of moles of that component divided by total mole. So basically this is telling us the total number of moles of solute present in the total number of moles of solution. Okay, so if suppose x1 is the mole fraction of solute, okay, so it is basically saying the moles of solute that will be present in the total moles of the solution. So suppose we are having two components A and B. Okay, so the mole fraction of A I can write as number of moles of A upon total moles, that is Na plus Nb. Similarly, for the mole fraction of B, I will say it is moles of B divided by total moles. Okay, so we can clearly see that Xa plus Xb will be 1. So if there are suppose n components in the solution, sum of all the mole fraction of all the component will always be equal to 1. Okay, suppose there are three components A, B and C, so the mole fraction of A would be number of moles of A upon total moles, that is Na plus Nb plus Nc. Similarly, mole fraction of B would be moles of B divided by total moles, that is Na plus Nb plus Nc. Similarly, mole fraction of C would be moles of C divided by total moles, that is Na plus Nb plus Nc. Okay. So this is a very basic about mole fraction. Okay. So if you look at this, mole fraction basically does not carry any unit because it is the ratio of moles. So the unit get cancelled out. So basically it is a dimensionless quantity. Okay. So just write it down quickly. Okay. I hope you have written this. Now next come is a very important term, that is molarity. Now we know that molarity is basically the number of moles of solute divided by volume of solution in liters. So basically number of moles of the solute present per liter of the solution tells us about the molarity. This is also called as concentration. Okay, so molarity unit is capital M, or we can write it as mole per liter. Okay. So suppose we have been given that a solution is 0.1 molar in HCl. So what it means? It means that in a 1 liter solution we are having 0.1 moles of HCl. So we can say that 1 liter solution contains 0.1 moles of HCl. Okay. I hope this is clear to everyone. So you can just write it down. Now there are two very important concepts in molarity. The first one being dilution. Okay. So what do we mean by dilution? Now when we are diluting any solution, it means that we are increasing its volume. Okay. So when we are increasing its volume, we know that molarity is number of moles upon volume of solution. Okay. So volume of solution in liters. So when you are diluting, it means you are adding more and more of solvent. So the volume of the solution will increase, so the molarity would decrease. So basically dilution is the addition of solvent so as to decrease the concentration of the solution. Okay. So let us take an example to understand this. So suppose we are having a container in which we are having, say, HCl. Okay, so this is the some volume of HCl and we know its molarity as, say, M1. So suppose this is HCl whose molarity is M1 and volume is V1. Okay. Now suppose to this solution we add water. Okay. Suppose we are adding water to this. So we are basically adding the solvent over here. So what we will say that the total volume of the solution would increase. Okay, because we have added the solvent. So the total volume of the solution has increased. Now because the total volume has increased, so its concentration would also decrease. Okay. So this is basically the HCl now. Now the molarity of the solution suppose became M2, volume became V2 upon addition of water. So what we can say in this is, if you look at this, what we are doing, we are just adding solvent to this system. Okay. When we are adding solvent to the system, we will say that the amount of solute that was present over here will be still equal to the amount of solute that is present over here, because we are not adding any solute to this solution, we are adding only solvent. So while dilution, we will say that the amount of solute remains constant. So we will say that amount of solute remains constant. So we can say that number of moles of solute initially should be equal to the number of moles of solute finally. Okay, because we have not added any solute to this, we have added only solvent. So the amount of solute which was present over here is still the same which is present over here. So we know that molarity is number of moles upon total volume of solution in liters. So molarity into volume of solution is liter will give us the total number of moles of solute. So total number of moles of solute initially was m1 into v1, because its molarity was m1, volume was v1. Finally it would become, the molarity became m2 and volume became v2. So the final number of moles of solute would be m2 into v2. So we'll say that m1 v1 is equals to m2 into v2. So this is the case of dilution. So whenever you are diluting, we are basically going to use this equation. Okay, so just write it down. I will show you some examples on this, some basic level problems. Okay, so just let us take an example. Suppose we have been given a solution whose molarity is 0.1 molar and say 100 ml. Okay, so we are having 0.1 molar, 100 ml HCl. From this 0.1 molar HCl, we want to prepare a solution whose molarity is say 0.025 molar HCl. Okay. So what we are doing, this is called as the stock solution or the mother solution, because this is the main stock from where we are taking out HCl. So suppose in lab we are having 0.1 molar of HCl 100 ml. Now in some reaction we want to use 0.025 molar of HCl. So what we are going to do, we are going to dilute this HCl because we want to decrease the concentration. So let us assume that V amount of water is added to it. Okay, so the question can come, what is the volume of water that has to be added in a 0.1 molar HCl solution 100 ml so that it becomes 0.025 molar. Okay, so initial volume we know is 100 ml, initial molarity is 0.1 molar. Okay, final molarity is 0.025 molar, and let us assume that the final volume is V2. Okay, because this is the case of dilution, so we'll directly say that m1 into v1 is equals to m2 into v2. Okay, number of, now m1 and v1, m1 into v1 will indicate number of millimoles of HCl because we are taking volume in ml. So this would be basically 0.1 into 100. This would be m2, which is 0.025 into v2. Okay, so this will get cancelled out and we'll get the volume as 400 ml. Okay, so the volume of the solution is 400 ml. Okay, so 100 ml solution initially was there. So when we are converting it, we need to have 400 ml solution. So the volume of water added would be 400 minus 100, that is 300 ml. Okay. So I hope this case is clear to everyone. Now a second important concept is known as mixing of two solution, mixing of two same solution. Okay, so let us take an example. Suppose we are having a container in which suppose we are having some solute dissolved in water. We have called this solution as solution A. Okay, the molarity of this solution, let us assume it is m1 and the volume of the solution is v1. We are taking the same solute dissolved in different quantity of the solvent water. Okay, so solute in this case is same. If suppose in A the solute is HCl, so the solute in this is also HCl. Okay, so let us assume that the molarity of this solution is m2 and volume is v2. Okay, so basically we are mixing two solution. Okay, the two solution are same, so this is basically mixing of two solution. Let us assume that this is HCl. So this is also HCl but of different molarity and volume. Now what we are doing, we are mixing them in a common container. Okay, so we have just mixed this two solution in a common container. So when we mix them, we know that the volume would become V1 plus V2. Okay, so the volume of this solution is V1 plus V2. Because volume has changed, so the molarity of the solution will change. Now let the molarity of the new solution be M nu. So we want to basically find the molarity of the new solution. So we know that in the initial beaker A, the number of moles of solute were M1 into V1. Okay, in the beaker B, the number of moles of solute was M2 into V2. Okay, so number of moles of solute in beaker A was M1 V1, number of moles of solute in beaker 2 was M2 V2. Okay, so when we are mixing it over here, so the total number of solute in the final solution would be M1 V1 plus M2 V2. Okay, and we know that the molarity is number of moles of solute divided by volume of solution in liter. So basically the molarity of this solution would be total moles of solute, that is M1 V1 plus M2 V2 divided by total volume, that is V1 plus V2. So this would be the formula for mixing of two same substance. Okay, I hope this is clear to everyone. You can just write it down. So this is one case of dilution, then the other cases of mixing. Okay, so I hope this is clear to everyone. Now let us solve a question on this. Okay, so let me give you one question on this. My question is something like this. Suppose we are saying that we are having a solution which is labeled as, a solution is labeled as 36.5 by mass in HCl. Okay, the density of the solution is, say, 1.5 gram per ml. Okay, we need to find the molarity of this solution. Okay, so I have already told you, whenever a data of mass percent has been given to you, you just have to decipher that data, you just have to write it and that's it. There is no formula for it and you have to use that data. So in question you have been given that the solution is labeled as 36.5 by mass in HCl, so I can say that the 100 ml solution, okay, so I can say that the 100 ml of solution contains 36.5 gram of HCl. Okay, so I know that in this the mass of HCl is 36.5 grams. The number of moles of HCl would be mass of HCl upon its molar mass. Okay, number of moles is always mass upon molar mass. So mass of HCl, we have seen that it is 36.5, molar mass is also 36.5. So the number of moles is 1. So basically what we are doing, we are having a 100 ml solution in which there is only 1 mole of HCl. So the volume of the solution is, we have to find out, because for finding molarity we need to have the number of moles of solute and the volume. So for volume data we have been given a density. Now we know that density is mass of solution upon volume of solution. Okay, now in this we have assumed that the mass of the solution is 100 ml. So density we know is given as 3/2 mass of solution is, sorry, this is 100 gram, okay, this is 100 gram, sorry, because this is mass percent, so it is 100 gram solution, okay. So 3/2 mass of solution is 100 upon volume of solution, so you can find the volume of solution as 200 by 3, this would be in ml because density is gram per ml and mass of solution is also in grams. So I can write the volume in liters as 0.2 by 3. So this is the volume in liters. So we know the volume also 0.2 by 3 liters. So molarity of this solution would become number of moles of HCl upon volume of solution. Okay, so number of moles of HCl is 1. Volume of the solution is 0.2 divided by 3. Okay, so I can write this as 3 by 0.2, which is 30 by 2, or I can write this as 15 molar. Okay, so this is how you solve a question when density and mass percent of a solution is given to you to find out the molarity. Similarly, in the same way, molarity would be given to you and say mass percent is given to you. So from that data you can also find the molarity, or sorry, you can also find out the density of the solution. Okay. So this is the concept which you are using. There is no need to remember any formula, because the more you remember the formula, difficult it would be to retain those formula. So the best thing is just solve through the concept. In the end, just before the examination, say 2 or 3 months before the examination, we are going to memorize all the formulas. Okay. Now let us look at the other concept, that is molality. Now molality is basically the number of moles of solute dissolved per kg of solvent. So molality we write as number of moles of solute divided by mass of solvent in kg. Okay. Molality is represented by small m. So if we say that we are having 0.1 molal solution, it means that 1 kg of solvent contains or is mixed with 0.1 mole of solute. Okay. 0.1 mole of solute. Okay. Now there can be very much of a interconversion questions. Now how you can do the interconversion questions? They are again basically logic based only, so there is no formula required for that. Suppose we want to convert molarity into molality. Okay, suppose we want to convert molarity into molality. So when we know about molarity, so basically we are knowing number of moles of solute. Okay, if we know the molarity, that means you know the number of moles of solute and the volume of solution in liters. Okay, suppose 0.1 molar HCl is given to us, so we'll say that 1 liter of solution contains 0.1 mole of HCl. So we know the moles of solute, we know the volume of the solution. To find out the molality, we know it is number of moles of solute upon the total weight of solvent. Now we know the moles of solute over here, but we don't know the mass of solvent in kg. But if we have been given a data of density, so if density is known to us, okay, so density is basically mass upon volume. So if density data is given to us, we can find the mass of solution. So mass of solution would be basically density into volume of solution. Now just we have to check on the units. Density has to be in, if you want to get the mass of solution in grams, so density has to be in gram per ml and the volume has to be in ml. So if it is given liter, if you have taken it in liter, you have to convert in ml. So you'll get the mass of solution. Okay. Now this will get in grams. Okay. Now we want to find the mass of solute. So for mass of solute, what I would need over here is the mass of solution minus the mass of solute. Okay. Also I know the moles of solute, I would know the molar mass. So I will multiply the moles into moles of solute into molar mass of solute. Okay. capital N sol is molar mass of N solute. So we'll get this quantity also. We know this, when we subtract, we will get the mass of the solvent. Okay, so we'll get the mass of the solvent over here. Now we can convert it into, because this will be in gram, we'll convert into kilograms. We'll have the mass of solvent in kg, and then we'll divide number of moles of solute upon mass of solvent in kg. We'll get the value of molality. So for converting molarity into molality, we would need the data of density. Okay, suppose we have been given that, say 0.1 molar HCl, okay, whose density is say 1 gram per ml. Okay, 0.1 molar HCl, density is 1 gram per ml. Say the question says find the molality of this solution. So what I am going to say that 0.1 molar HCl means that 0.1 moles of HCl is present in 1 liter solution or 1000 ml solution. Okay, so we know the volume of solution as 1000. Okay, density we know. So mass of solution would be density into volume, which is 1000 into 1. So that would be 1000 gram. Okay, so to find out the mass of solvent in kg, we need to get the mass of solute. So mass of solute would be number of moles of solute into its molar mass. So molar mass of HCl is 36.5. So it is 3.65. Okay, so the mass of solvent in this case would be 1000 minus 3.65. Clearly you can see this is 996.35 grams. So I can write this as 0.99635 kg. Okay, so to calculate the molality, what I will do, we know the moles of solute as 0.1, will divide by the mass of solvent in kg, we'll get the molality. Now you can see this is basically 0.1 divided by 0.99. So approximately it will be equal to, very close to the value of molarity. So we assume that for very dilute solution, if the solution is highly diluted, so the molarity and molality are always same. Okay, so for very dilute solution, we'll assume molarity and molality to be same. Okay. Now if we want to convert, first write this. I hope this is clear to everyone. So to convert molarity into molality, we would need density of the solution. But if nothing has been given to us in terms of density of solution, then we'll say that the solution is dilute and we'll assume that molarity and molality are equal. Okay. So if we want to convert molality into molarity, okay, suppose if we want to convert molality into molarity, okay, so what we'll do over here is, when we know the molality, so we know the moles of solute and the mass of solvent. Okay, so because we know the molality, suppose it has been given to us that 0.1 molar HCl is there. So we'll say that 1 kg of water contains 0.1 moles of solute. So because we know the mass of the solvent and we know the number of moles of solute, so we can get the mass of solution. Okay, so the mass of solution would be mass of solvent into mass of solvent plus number of moles of solute into molar mass of solute. Okay, number of moles of solute into molar mass of solute will give us the mass of solute. So this is basically mass of solute plus mass of solvent. So we'll get the mass of solution. So again, for calculation of molarity, we would need number of moles of solute, which we know over here, divided by volume of solution in liter. So we have to find the volume of solution. We know the mass of solution. So again we need density over here. So if a density is given to you, so I can write volume as mass of solution upon density. Okay, so just check the units. So if this volume comes out to be in ml, so you have to convert into liters. So we'll get the volume, we know the number of moles of solute, we'll find the molality. Okay, we'll find the molarity. I hope this is clear to everyone. So this is how you interconvert. So for interconversion, you basically need to understand the concept and what parameters are required. You don't need to remember anything. Whenever it is given in the question, just apply the logics and try to solve that. If you are doing it regularly, then things would become easy and you will be able to solve it very quickly. So let us look at one question. Okay, so just look at this question. Try to solve this. I will also tell you a shortcut formula to solve this as well. So this question says that the mole fraction of iodine in benzene is 0.2. Find the molality of this given solution. Okay, so we know that we have been given molality of mole fraction of iodine as 0.2. So the mole fraction of benzene would be 0.8. To find the molality of the solution, we would need number of moles of solute. Okay, so out of iodine and benzene, which is the solute, because this is present in small quantity, so this would be the solute and this would be the solvent. So before finding the molality, just confirm which is the solute and which is the solvent. Okay, so the number of moles of iodine is 0.2, number of moles, mole fraction of iodine is 0.2, mole fraction of benzene is 0.8. Okay. Now suppose we want, if we take the ratio of the mole fraction, okay, so number of moles of iodine upon number of moles of benzene. Okay, we know that the mole fraction of iodine would be number of moles of iodine upon total moles. Total mole will be number of moles of iodine plus number of moles of benzene. Okay, mole fraction of benzene. Now mole fraction of benzene will be moles of benzene divided by total moles, that is moles of iodine plus moles of benzene. Okay, so these two will get cancelled out. So the ratio of mole fraction is also the ratio of the moles. Okay, so I can write this as number of moles of iodine, number of moles of benzene, I can write it as mass of benzene upon the molar mass of benzene. Okay, I can write number of moles of benzene as mass of benzene divided by molar mass of benzene. Okay, so if I take the molar mass of benzene above, so I will get number of moles of iodine upon mass of benzene into molar mass of benzene. Okay, so just look at this expression. We know that molality is number of moles of solute, which is iodine in this case, divided by mass of solvent, which is benzene in this case, in kg. Okay, so molality is number of moles of iodine upon mass of benzene in kg. Okay, so this is the molality. So you can clearly see that this term is over there. Okay, this term was over there, but we have expressed the mass in gram because this was mole, so this is basically in gram and this is basically gram per mole. So this mass is in grams, so we need to convert it into kilogram. So what I will do, I will multiply numerator and denominator with 10 raised to minus 3. Okay, I hope this is clear to everyone. So when you multiply this with 10 raised to minus 3, so this will be number of moles of iodine upon mass of benzene. I just absorb this 10 raised to minus 3 into this, so this will be in kg, into molar mass of C6H6 upon into 10 raised to minus 3. Okay, so that I can also turn upon 1000. So this is basically mole fraction of iodine upon mole fraction of benzene. So this term is your molality. So I will write molality as number of mole fraction of iodine upon mole fraction of benzene into this 10 raised to minus 3 will come over here into 1000 upon molar mass of capital M. C6H6 is basically molar mass and not the molarity. So don't get confused over it. So this is the formula. So I can just use the mole fraction of iodine as 0.2, mole fraction of benzene as 0.8, molar mass of benzene as 78, and I will get the molality. So I am expressing molality when mole fraction is given to us. So if you want to build a formula for this, okay, so I will say that molality is equal to mole fraction of iodine. Okay, iodine was solute, so I can write this as mole fraction of solute divided by, this is mole fraction of solvent, or 1 minus mole fraction of solute, okay, into 1000 divided by molar mass of benzene. Benzene was solvent, so I will write this as molar mass of solvent. So this is the way you convert mole fraction directly into a molality term. Okay, so if molality is known to you, we can get the mole fraction using the same formula, or if mole fraction is given to us, we can find the molality of the solution. Okay, so just write it down. Okay, so this is a very important formula. So if you remember this formula, this will actually help you, because this is going to be used in lot of solutions question as well, solutions and colligative property questions as well. So if you can remember this formula, then it will be very advantageous. You can just derive this, but it will take some time. For objective solving, it is recommended to just memorize this important fact. Okay, so I hope this is clear to everyone. Okay, so just solve this question now. So this question says that rectified spirit has 95% ethanol by weight. So rectified spirit is basically the mixture of ethanol and water. So this is saying it is 95% ethanol by weight. Okay, so if the solution is of 100 gram, okay, so 100 gram solution will contain 95 gram of ethanol. Okay, so the molar mass of ethanol, you can calculate this. This would be 46 gram per mole. Okay, and remaining amount of it would be water. So this is basically 5 gram of water. So the molar mass of water we know is 5. Okay, so don't confuse with capital M as molarity. So it is written like that only, but you know that it is molar mass. So number of moles of ethanol in this case would be 95 upon 46. Okay. Number of moles of water in this case would be 5 divided by 18. Okay. The molar mass of water is 18. So the total moles in this case would be 95 by 46 plus 5 by 18. So you can calculate the total moles. So the mole fraction of ethanol would be 95 by 46 divided by 95 by 46 plus 5 by 18. Similarly, mole fraction of water would be 5 by 18 divided by 95 by 46 plus 5 by 18. Okay, so this is the way to calculate. So I hope this is easily understood by you. So they are basically related to simple arithmetic calculation. Okay, so you just need to read it out properly. You need to understand what data have been given to us and how do we go and extract that data. Okay, so you have to understand what data was given to us and how we are extracting that data and using it for the benefit of the question and getting the answer. Okay, so just it is a matter of practice. If you practice more such kind of question, interconversion question, especially when you are converting molality into molarity, molarity into molality, mole fraction into molality, mole fraction density given converting into molarity, similarly mass percent given converting it into molarity or mole fraction. So such kind of questions, interconvertible questions are important over here. Okay, so you can just write it down now. Okay, so the last concept that we want to discuss for today is normality. Okay, so normality is basically defined as number of gram equivalents of solute upon volume of the solution in liter. Okay, so normality is basically number of equivalents of solute. Molarity was basically number of moles of solute divided by volume of solution in liter. Normality is number of equivalent of solute divided by volume of solution in liter. So how do we calculate the number of equivalent? Okay, so number of equivalent, number of moles was mass upon molar mass. So number of equivalent would be mass of, say in this case solute, divided by equivalent weight. Okay, so this is basically equivalent weight of, say, solute in this case. So in mole concept we talk about molar mass, in equivalent concept we talk about equivalent weight. Okay, so number of equivalent is basically mass of solute upon equivalent weight of solute. Now what is equivalent weight of solute? So equivalent weight of solute is written as okay, so equivalent weight I can write this as molar mass of that substance divided by a n factor. Okay. Now you might have studied this in redox chapter also. So n factor is, we define n factor. Okay. So if we are having acids, so n factor is the number of ionizable hydrogen. Okay, for a monobasic acid, N is 1, for a dibasic acid N is 2, for a tribasic acid N is 3. Or you have to see the reaction. Okay, if in the reaction acid is losing only 1 H, then the N factor is 1. If in the reaction a polytropic acid is losing 2 H, then the N factor is 2. If it is losing 3 H, then the N factor is 3. So for acids, N factor is number of ionizable hydrogen. Similarly for base, it is N factor is number of ionizable OH negative ion. Okay. For redox reaction, okay, for any redox reaction, we say that N is the number of moles of electron gained or lost by the substance. Okay. So you need to know the equivalent concept, basics of equivalent concept, N factor concept, how do we write equivalent weight, what is equivalent volume. Okay. So all these things will be used in solutions a lot, even it will be used in electrochemistry chapter as well. Okay. So for any acids, N is the number of ionizable hydrogen. ठीक है, जितना H प्लस छोड़ेगा उतना उसका N फैक्टर है. एक रिएक्शन में अगर कोई एक एसिड 2 H प्लस छोड़ रहा है तो उसका N फैक्टर 2 होगा. अगर वो 3 H प्लस छोड़ रहा है तो वो 3 होगा. ओके. अगर कोई बेस, सपोज बेस लाइक KOH, we know that KOH will only liberate 1 OH negative. Okay, so the N factor in this case would be 1. कैल्शियम हाइड्रोक्साइड लोगे तो कैल्शियम हाइड्रोक्साइड में 2 OH नेगेटिव है तो पानी में 2 OH नेगेटिव जाएगा तो N फैक्टर उसका 2 हो जाएगा. सिमिलरली कोई भी रिडॉक्स रिएक्शन है, रिडॉक्स रिएक्शन बेसिकली इसका मतलब ये कि इस किसी चीज का ऑक्सीडेशन हो रहा है या रिडक्शन हो रहा है, तो जिस स्पीशीज का ऑक्सीडेशन हो रहा है अगर हमें उसका N फैक्टर निकालना है, राइट, जिस चीज का ऑक्सीडेशन हो रहा है अगर हमें उसका N फैक्टर निकालना है तो आई विल से दैट इट इज द नंबर ऑफ इलेक्ट्रॉन लॉस्ड बाय दैट स्पीशी. 1 मोल सब्सटेंस जितना इलेक्ट्रॉन लूज करेगा वो उस स्पीशी का N फैक्टर होगा. Similarly, if a reactant is undergoing reduction, so the number of moles of electron gained by 1 mole of the substance during the reduction reaction would be its N factor. Okay. Salts ka generally we say that N factor is the total positive or negative charge. Okay. And for ions we say that it is equal to the charge. So magnitude of charge is the N factor. Okay. But basically we are interested in the first 3 cases. Okay. Because we solve redox question through it. So reactions would be given to us. So through reactions we have to look at the N factor. Okay. So I hope this is clear to everyone and you have done this in your 11th class. If not, then you can revise it. You still have some days left with you before we start the solution chapter. Okay. So number of equivalents is similar to the mole concept, is a equivalent concept. In mole concept we talk about molar mass, in equivalent concept we talk about equivalent weight. So equivalent weight is basically molar mass upon N factor. So N factor can be calculated something like this. Okay, given upon the compound which has been given to you in the question, you can get the N factor from there. So if I write this as equivalent, okay, so if I plug this value back to this, so I can write normality as number of moles of solute divided by equivalent weight. I know it is molar mass upon N factor, capital M again is representing. Okay, so if you are confused, just you can write this as molar mass upon N factor. Okay, so normality I can write this as number of moles of solute, okay, divided by molar mass into N. Okay, so we know that the number of moles of solute upon molar mass. Okay, oh sorry, we have like did a very big blunder over here. Okay, so let me just show you what blunder we have done. Okay, the blunder was here only initially, so just I am erasing this. So number of equivalent was number of equivalents. Oh no, we are doing. Oh, okay. Number of equivalent was, it was right only. So this is mass upon equivalent weight. Okay. So equivalent weight we express something like this. Now normality was, here was the problem. Okay. Normality was let me just erase this. I will write it again. So normality was number of equivalents of solute upon volume of solution in liters. So number of equivalent I can say is mass upon equivalent weight. Okay, number of equivalent mass upon equivalent weight. Equivalent weight I know is molar mass upon n factor. So this is basically the number of equivalents upon volume of solution in liter. Okay, so I can write this as mass upon molar mass is also number of moles. So this will become number of moles upon n into volume in liters. So this is basically normality. Number of moles upon volume of solution in ml is molarity. So I can write normality will be equal to molarity upon n factor. Okay, so molarity is normality into n factor. So again a very important conclusion. So I will say that molarity is always equal to n factor into normality. So this we use frequently in all our questions in redox as well as solutions and electrochemistry question. So just have a note of this. So this is actually important. So just have a note of it. I hope this will keep your eye glued upon this as it will shine. So I hope you have understood how we are deriving this. So normality is nothing but number of equivalents of solute upon volume of solution in liter. Number of equivalent is mass upon equivalent weight. So number of equivalent is mass upon equivalent weight. Equivalent weight is molar mass upon n factor. So basically I replace equivalent weight by molar mass upon n factor. So I will get mass upon molar mass divided by n factor, whole divided by volume in liters. So this n will come out like with volume. So this is mass upon molar mass, which is number of moles, divided by n into volume in liters. So mass, number of moles of solute upon volume of solution in liter is also molarity. Okay, so this is normality equals to molarity upon n factor. So I can say that, okay, the molarity is equal to normality into n factor. Okay, so I hope this is clear to you. So just write it down. So if you are through with this, then it's actually very good. You are not going to face much of a difficulty in solution chapter. But if you still are forgetting, okay, if the revision is today is not sufficient, so you can just go back to your previous notes, you can just read it and you can solve some basic questions on that so that all the concepts are revisited. Okay, so just write it down quickly. Okay, I hope you have written this. So both the concept of dilution as well as mixing will hold true in the concept of normality as well. So if we are diluting a solution, so in that case we will say that the amount of solute remains constant because during dilution you are adding only solute. So we say that the amount of solute remains same because you are just adding solvent. So amount of solute means moles of solute or equivalent of solute. So number of equivalents of solute will remain same. So number of equivalent of solute would be normality into volume. So we will say that N1 V1 equals to N2 V2. It is similar to that which we have written in molarity. So if we are mixing two same solution, just ensure that you are mixing two same solution. So when we are mixing the two same solution, so we'll say that the normality of the new solution is N1V1 plus N2V2 upon V1 plus V2. In the similar way, we did the molarity of the new molarity after mixing of two same substance. Okay. So this is it for today. We don't have much of a topic to discuss. So in the next lecture from Monday, we are going to start with the concept of vapor pressure and how vapor pressure is related to colligative property. So it will take some 7 to 8 lectures to complete the chapter. We are again going to do some problem solving in the class like we did for chemical kinetics. Okay. So I hope you are taking care of your health and I hope you are making a proper notes. Like one thing which is very important for the preparation of JEE. Okay, you should understand this. This is the only key to success and there is no other key to success. A teacher doesn't have the key for the result which you are looking for. Any system, any institute, any online platform will not give you any privilege. Okay, privilege will come to you or your result will improve only when you are doing it in proper manner. So a good guidance, a good academic system is what is required. So first and the foremost thing is the preparation of notes. I hope you are sincerely maintaining a very good notes. Without notes, I don't think this battle of JEE examination can be won. If you don't have a good notes, your chances of clearing the exam becomes very close to 0%, because the syllabus is humongous. You have a lot of content. Okay, if you look in chemistry only, there will be some 25 to 30 chapters. Similarly with physics and similarly with maths. So there are many chapters. So if you are maintaining a very good notes, okay, you are writing your notes, you are creating your notes by your own and not taking any Xerox of any of your friend, then that will actually help you. So whenever you are doing a theory, make sure that you are like writing a notes, creating a notes for yourself, and then you are referring some good book for reading. A good book for reading for physical chemistry is mostly NCERT. You need to be thorough with your NCERT line by line. Everything that is written in NCERT should be inside your head. So you have to first do the chapter over here, okay, then go back to NCERT. Once you have created the notes, read the NCERT. If you find there are some theoretical points in NCERT, find out theoretical details which should be there in your copy, so you have to incorporate in your copy. Okay, and for extra reading you can read, there are 2 or 3 good books that you can read. One is K.S. Verma, Physical Chemistry. Okay, it comes in 2 volumes, 11th and 12th. You can use both the volume if you want. And similarly, there is a book called Ranjit Shai. But according to me, K.S. Verma is a little better book. So it depends upon kids to kids what they like. But my preference would be K.S. Verma. Okay, so make a very good notes. The key to success is in the notes. Because once the preparation is over, once we have completed the chapter, you need to revise. And revision should never be done through a teacher. Revision should always be done through a personal effort. So you should revise everything, then you should attempt few content. Then if you are facing any problem, any doubt, you should write to your teacher or you should contact your teacher, you should take your doubt. That is the only way of moving ahead. If you are creating any of if you are leaving any of the path, then definitely it is going to create a lot of problem. Okay, so make a good note, ensure that you are solving a good level content. Reading is a very important tool, because when you are reading, your senses are awakened. You are basically, mind is focusing, you are also reading, your eyes are also moving. So basically you feel more connected to the topic, and that is what is required. While reading, there is a conceptual picture that is getting developed in the mind. That is the art of preparation. So it's not about just solving. The biggest problem with most of the people is they just want to solve. Solving would definitely increase your solving skill, but it won't help you in retaining the content. For retaining the content, you have to read, you have to write, you have to keep on solving. So if you do it in a proper blend, so everything will be easily memorized by you, because chemistry requires a lot of memorization. So you cannot be sure that if you are 100% ready for it or not. So read, write, solve. Any doubts, write to us, write to me. I will try to help you in all possible ways so that your preparation is basically going forward in a much positive manner. Okay. So we have uploaded the daily revision sheet for today. So you can daily practice problem sheet for today. You can solve the daily practice problem for today. Then start with the solutions portion. Okay, that is we are going to start with Raoult's law. Okay, so I hope everyone is taking care of yourself, and basically you are staying home, staying safe, and working out a very effective plan for your preparation. Okay, there is no need to get disheartened, or there is no need to feel any anxiety about your preparation. Preparation is still going on and it will keep going on. You need to stay focused, you need to be grounded, and you need to analyze your weakness, and you need to move ahead. Okay, so I hope these are the small points that you are taking care of, and definitely if you are following us, if you are there with us, I especially promise you that I will take you to the destination where you want. Okay, so this is Animesh signing off for now.